For the next example, we have y equals sine of 1/2 x plus pi over 2. So if we use the formula as is, c in this case would be pi over 2. It would actually have a negative in front as well because it was supposed to be x minus pi over 2. So we'll have c to be negative pi over 2. b will be 1/2. So we'll do negative pi over 2 divided by 1/2. When you multiply by the reciprocal, you'll get negative pi. Having a phase shift of negative pi means the graph is going to move left by pi units. Now, you could also factor that 1/2 out and find the phase shift that way instead. So what we could do is if you take 1/2 out, you'd be taking a 1/2 both from the 1/2 x and from the pi over 2. So 1/2, when you divide pi over 2 by 1/2, that's going to give you pi. Or you can think of it as 1/2 times what gives me pi over 2? Well, that answer would be pi. So if I looked at it this way, by factoring out that b, we would get that this graph moves left pi units, which means I would have a phase shift of negative pi. So in this particular case, my blue graph is my sine function. That's the parent function. And so one of the things that my graph is doing is it is moving left by pi units. So you can see that here from this part where the graph began and made its first peak, it's now going left pi and making its first peak. Okay. The second thing that you'll notice happened is that this thing became wider. It's actually being horizontally stretched by 2. Remember, we take the value of b and we do 1 over b. So if you have b between 0 and 1, you're actually going to have a horizontal stretch instead, and it's going to be by 1 over b. So if I do by 1 over 1/2, that'll be 2. And so what that means is that it is 2 times longer than it originally would have been. And so what you'll notice is if you go from negative pi to the end where it would start all over again, for sine would be here at 3 pi. So now it's going from negative pi all the way to 3 pi, and that is actually 4 pi units. And so it is now 4 pi units long to create one cycle of the red function. And so that's what the horizontal stretch by 2 means. It also means, if you remember from the previous slide when I was talking about b being the number of cycles that you see from 0 to 2 pi. So in this particular case, from 0 to 2 pi, you'll notice you only see half of the graph. So you'll see this half of the graph, but it's missing this part of the graph and this part of the graph, which is the other half of the graph. So that's why it says the 1/2 is the cycle from 0 to 2 pi of how many times you would see it. In this case, you would only see half of it. And so now we'll do an example together. So this will be our example 2, where we're going to actually draw it from scratch from the very beginning. And so if you will, go ahead and pause the video and write down the transformations. So for this first one, we have a vertical stretch by 3, and the graph goes down 2. These are going to be the tough parts right here. Okay? So just like when we were in Algebra 2, we factored out a negative, you absolutely have to factor this out first because it looks like it's going right pi over 6, but it actually is not. So what we'll do is we'll factor out the 1/3. That becomes x minus. In order to factor it out from this pi over 6, technically you're dividing pi over 6 by 1/3 in order to be able to take it out. So you'll multiply pi over 6 by 3 instead, and that gives you 3 pi over 6, which reduces down to pi over 2. So this will be pi over 2 here. So instead of going right pi over 6, this actually goes right pi over 2 units. And then this part, because b is between 0 and 1, this is actually going to be a horizontal compression. And you flip the reciprocal. Oh, I lied. This is going to be a horizontal stretch, not a horizontal compression, I'm sorry. horizontal stretch, and you flip the reciprocal of b, and it's going to be a horizontal stretch by 3. All right, this time cosine is our parent function, so we'll take our parent function graphs, those 5 key points that we were talking about earlier. They're still going to be your quadrantal angle, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we're going to go through the unit circle. Cosine of 0, if you're at 0 degrees, the cosine is 1. If you go straight up, the cosine of pi over 2 is 0. If you go to pi, the cosine is negative 1. If you go to 3 pi over 2, the cosine is 0. And if you go to 2 pi, the cosine is 1. So these are the points that we're going to be transforming. We'll use these formulas to make that happen. In order to vertically stretch this by 3 and make it go down 2, we've got 3y minus 2. In order to make this horizontally stretched by 3, that means make the x's 3 times bigger. We'll do 3x, and we want it to go right pi over 2 units. So there's our formula, 3x plus pi over 2. So we'll take all of these formulas and we'll multiply them, or we'll take all these x values, multiply them by 3 and add pi over 2. Take all these y values, multiply by 3 and subtract 2. So you can go ahead and do that now. So for pi, we have 3 pi over 2 plus 1 pi over 2, which is going to give me 4 pi over 2. That'll be 2 pi. For pi, I'll have 3 times pi plus pi over 2. I'll get a common denominator. This is the same thing as 6 pi over 2 plus pi over 2, which is 7 pi over 2. 3 pi over 2 times 3 is 9 pi over 2. If I add pi over 2 to that, that becomes 10 pi over 2 to give me 5 pi. And then 2 pi times 3 is 6 pi plus pi over 2. It's the same thing as 12 pi over 2 plus pi over 2, which is 13 pi over 2. And I have my new points. So it's 4 pi, that means this must be 2 pi, this must be pi. So now we'll graph pi over 2 comma 1, 2 pi comma negative 1. 4 pi is the same thing as 8 pi over 2. 2 pi, this is 3 pi, that's the same thing as 6 pi over 2, so 7 pi over 2 must be directly in the middle. And then that's going to be at negative 5. Oh wow, I don't even have room for that one. Doesn't seem like it should be that far down. I think I may have made a mistake. Negative 3, nope, negative 5, that looks right. 3 times 1 is 3, minus 2 is 1. Well, these are right, okay. Oh, I just didn't graph my 2 pi correctly, that's what it was. I used to 2 pi negative 2. And then 5 pi, no, 7 pi over 2 will be here, comma, negative 5. That's pretty far down. All right, 8 pi over 2. This is going to be 6 pi. This will be 5 pi, 7 pi. I need 5 pi, negative 2. This is going to be 12 pi over 2 and 14 pi over 2. So this will be 13 pi over 2 in the middle, comma 1. So there's my graph. We'll connect your dots. You'll notice you still have the sine function's general shape. And now you would continue the rest of this for the next point. So the next point after this one would be 1.5 away. So that's a half and then 1. So this will be here. Each of these are 1.5 pi, 1.5 pi's away. So there was 1 full pi and then half of 1. So that's how I got this one. So this will come back down. And then I'll go 1 full pi and then half. to get this next one here. Then half a pi and then one full one to get this next one here. So I'll connect these dots. Same thing here. Here's half a pi and one more full one. So that'll be a point there. And then there's the rest of the graph. And that's it. All right, to graph the other ones, we would do very similar things as we did for the sine and cosine. This is the only ones that we have to be careful of about these are the vertical asymptotes though, okay? So when I go to graph these, I just have to be mindful of those vertical asymptotes and where those occur. So this is going to be section 4.6. For cosecant, we're still going to use the same values. Those key points that I use for sine and cosine will be the same key points that I use for this one as well. So your quadrantal angles. All right, cosecant, if you remember, is a reciprocal of sine, so keep that in mind. So when I do this, you can picture a unit circle in your brain. If you're at 0, the graph is sitting at 1, 0, the point, so the sine of this point is 0. But when you take the reciprocal of that, you're going to have undefined. This is going to be where the first vertical asymptote of cosecant is going to be. When I go to pi over 2, it's 0, 1. The reciprocal of the sine, which in this case is 1, is still 1. When I get to pi, I'll have the same issue. My y is 0 again, so I'm going to have another vertical asymptote at pi. And the same thing will happen at 2 pi as well, so I'll go ahead and put that there. For these undefineds, keep in mind these are going to be your vertical asymptotes. And then for 3 pi over 2, we've got 0, -1. The y value here is -1. If I take the reciprocal of that, I still get -1. All right, using my transformations, which in this case are vertical stretch by 2 and left pi over 4. I'll make my formulas. And then I'll take these values and I'll run them through these formulas. So the first one will be negative pi over 4. Pi over 2 minus pi over 4 is still positive pi over 4. 3 pi over 2, it's the same thing as 6 pi over 4 minus pi over 4 is 5 pi over 4. And then 2 pi is 8 pi over 4, so that'll become 7 pi over 4. Okay, and so apparently I forgot to put pi in here as well, so I apologize for that. So right here, we're going to do pi minus pi over 4. That's going to be the same thing as 4 pi over 4 minus 1 pi over 4. So we'll get 3 pi over 4 here, so I apologize for that. Now we'll take all those values and double them. You'll notice that this has no value because it's undefined, which means I'll still have a vertical asymptote at these same spots. So that'll be the first spot, the middle spot, and the last spot. And then this value at 1 will be doubled, and the same thing with -1. So now I have values that I can plot. So negative pi over 4 would be here. This first one, that's going to be your first vertical asymptote. And then positive pi over 4 is going to be here. There's your second vertical asymptote. No, I lie. Pi over 4 is not a vertical asymptote. It is a value at 2. So here's pi over 4 comma 2. 3 pi over 4 is going to be your next vertical asymptote. That's going to be here. And then this is 4 pi over 4. This is 8 pi over 4. So in the middle we have 6 pi over 4, or the same thing as 3 pi over 2. So that means 5 pi over 4 will be here. There's a point there. And then my last one, oops, and a vertical asymptote at 7.